SYJC Chapter 3b, Elasticity of Demand. Part 5, Methods of Measuring Price Elasticity of Demand. 1. Ratio or percentage method. Ratio method is developed by Professor Marshall. According to this method, elasticity of demand is measured by dividing the percentage change in demand by the percentage change in price. Percentage method is also known as arithmetic method. Price elasticity is measured as ED equals percentage change in quantity demanded / percentage change in price. It means elasticity of demand is relatively inelastic. 2. Total expenditure method. This method was developed by Professor Marshall. In this method, total amount of expenditure before and after the price change is compared. Here the total expenditure refers to the product of price and quantity demanded. Total expenditure equals price times quantity demanded. In this connection, Marshall has given the following propositions. A. Relatively elastic demand, ED greater than 1. When with a given change in the price of a commodity total outlay increases, elasticity of demand is greater than 1. B. Unitary elastic demand, ED equals 1. When price falls or rises, total outlay does not change or remains constant, elasticity of demand is equal to 1. C. Relatively inelastic demand, ED less than 1. When with a given change in price of a commodity total outlay decreases, elasticity of demand is less than 1. This can be explained with the help of the following example. In table, in example A, original price is 10 per unit and quantity demanded is 6 units. Therefore, total expenditure incurred is 60. When price rises to 20, quantity demanded falls to 5 units, the total expenditure incurred is 100. In this case, total outlay is greater than original expenditure. Hence, in this example elasticity of demand is greater than 1. ED greater than 1, that is relatively elastic demand. In example B, original price is 30 per unit and quantity demanded is 4 units. Therefore total expenditure is 120. When price rises to 40, quantity demanded falls to 3 units. Total expenditure incurred is 120. In this case total outlay is same, equal, to original expenditure. Hence, in this example, elasticity of demand is equal to 1, ED equals 1, that is unitary elastic demand. In example C, original price is 50 per unit and quantity demanded is 2 units. Therefore total expenditure is 100. When price rises to 60, quantity demand falls to 1 unit and total expenditure incurred is 60. In this case total outlay is less than original expenditure. Hence, elasticity of demand is less than 1, ED less than 1, that is relatively inelastic demand. 3. Point method or geometric method. Professor Marshall has developed another method to measure elasticity of demand, which is known as point method or geometric method. The ratio method and total outlay methods are unable to measure elasticity of demand at a given point on the demand curve. At any point on the demand curve, elasticity of demand is measured with the help of the following formula. Point elasticity of demand, ED, equals lower segment of demand curve below a given point, L, upper segment of demand curve above a given point, U. Demand curve may be either linear or nonlinear. A. Linear demand curve. When the demand curve is linear, i.e. a straight line, we extend the demand curve to meet the y-axis at A and x-axis at B. Price elasticity of demand at x-axis is 0 and y-axis is infinite. Elasticity of demand will be different at each point. B. Nonlinear demand curve. When the demand curve is nonlinear, i.e. convex to origin, to measure price elasticity of demand we have to draw a tangent at touching the given point on the demand curve and extending it to meet y-axis at point A and x-axis at point B.